All right, let's talk about the unsung heroes of our modern world. I'm talking about batteries. We're going to crack open these little powerhouses and see what makes them tick. From your phone to your car, it's all about some really cool chemistry. So let's get into it.
Seriously, have you ever stopped to think about it? You pop a battery in and things just work. But what's the magic going on inside that little can? What's the secret sauce that brings our gadgets to life? Well, that's exactly what we're going to unpack today.
Okay, so first things first. Let's get down to the basics. What even is a battery? It's funny because whether you're looking at a teeny tiny one for your watch or a giant one that powers a car, they all work on the same fundamental blueprint. Think of it this way. A battery is basically a can of potential. It's a self-contained chemical reaction that's just paused. It's holding all this energy in reserve, waiting for you to give it the green light. The second you turn something on, you close the circuit, and boom, that stored chemical energy transforms into electrical energy. And to make that happen, you need three key players. You've got the anode, which is the negative side. Think of it as the starting gate where all the electrons are lined up. Then you have the cathode, the positive side. That's the finish line. The third ingredient is the electrolyte. It's kind of like the racetrack itself, or maybe the referee, making sure everything flows smoothly between the two. When you flick a switch, you're basically yelling, go! The electrons race from the anode to the cathode through your device, and that flow, that stampede of electrons, is what we call electricity.
All right, let's look at a real-world example. We'll start with an old-school classic, the one you've probably got in a junk drawer right now. Yep, I'm talking about the battery for your TV remote or that old flashlight, the Humble Dry Cell.
And here it is, the inside of your classic AA battery. It might not look like much, but every single piece in there has a critical job. Let's pull it apart and see how it works. Now, this is where the design gets really clever. See the outer casing? That's not just a container. That is the anode, the negative part. It's made of zinc. And that rod running right down the center, that's your cathode, the positive part, made of carbon. Everything is packed in this moist, salty paste. That's the electrolyte. It's a super simple, super cheap, and really effective design, perfect for things that don't need a whole lot of juice. Okay, but what happens when you need some serious muscle? I'm talking about the kind of raw power it takes to crank a car engine over on a cold morning. A little AA battery isn't going to cut it. For a job that big, you need a real heavy hitter. And that would be the lead-acid battery, the beast that lives under your car's hood. The secret to its brute strength is right there in the picture. Look at all those plates. You've got multiple positive and negative plates stacked together. This creates a huge surface area, which means the chemical reaction can happen all at once, everywhere, delivering this massive, instantaneous jolt of electricity, exactly what you need to start an engine.
But here's the best part, right? It's rechargeable. So when you turn the key, the battery discharges. The chemicals react and zap your engine to life. But then, as you're driving, your car's alternator kicks in. It's like a built-in generator that shoves electricity back into the battery. This forces that whole chemical reaction to run backwards, basically resetting the battery, getting it all primed and ready for the next time you need to start the car. It's a beautiful cycle.
Okay, from the workhorse to the marathon runner, let's talk about the thing that powers the device you might even be watching this on. Your phone, your laptop, all these gadgets that need a lot of power, but also have to be light enough to carry around all day. That's where the lithium-ion battery completely changed the game. This is a fantastic visual of how it works. When you plug in your phone to charge, what you're really doing is forcing tiny lithium ions to move from one side, the cathode, over to the other side, the anode. You're basically packing them full of potential energy. Then, the moment you unplug and start using your phone, those ions want to go back home. They flow back to the cathode, and that movement, that flow, releases the energy that powers your screen and everything else. And I love this analogy because it's perfect. The lithium ions are like a person in a rocking chair. They just rock back and forth, from the anode to the cathode, and back again. They don't get used up, they just ferry the energy from one place to another. It's such an elegant and efficient way to store and release power. Whoa, okay, chemistry alert. But don't worry, you don't need to be a chemist to get this. This is just the sciencey way of writing down the rocking chair thing. You can see the Li, that's our lithium ion, moving from the cobalt oxide side over to the carbon side. It's the exact same back and forth dance we were just talking about. All right, so everything we've talked about so far has been about storing energy. You charge it up, you use it, you recharge it. But what if you had something that didn't store power at all, but made it right on the spot for as long as you gave it fuel? Well, that's a whole different ballgame. That's a fuel cell. At first glance, this might look like another battery, but look closer at the arrows. You see stuff going in and stuff coming out. That's the key difference. A battery is a closed box. A fuel cell is an open system. It's constantly taking in fuel, like hydrogen and oxygen, and generating electricity in real time.
And what's so amazing about this process is how clean it is. You feed hydrogen gas to one side, and you feed oxygen, just from the air to the other. They react, they create electricity, and what comes out the other end? Just a little heat and pure water. That's it. Nothing burns, no nasty emissions. It's pretty incredible.
Okay, so we've looked at the simple dry cell, the powerful car battery, the lightweight lithium-ion, and the on-demand fuel cell. 4 totally different approaches to power. So let's wrap this up and look at the big picture, see where each one fits. And this table really says it all, doesn't it? It shows that there isn't one best battery. It's all about the right tool for the right job. You need something cheap and simple for a remote? Dry cell. Need a huge burst of power for your car? Lead acid. Need something light that lasts all day for your phone? Lithium-ion is your guy. And if you want to generate clean power with 0 emissions, you're looking at a fuel cell. Each one is a winner in its own category. Which really leaves us with a fascinating question to think about, right? Our future is becoming more and more electric every single day, so what's going to power it? How will these incredible little chemical engines evolve? And what new ones are just around the corner? The answer to that is really going to shape the world we live in. Thanks for diving into this with me.